Hello student, last class we done electric field intensity and we define it and derive the formula for the electric field due to a point charge and understood about on which quantity it will depends. Now in this class we discuss about electric field lines of forces and its properties. So first, what is electric field? So student, these are a pictorial representation of the electric field, or these are the imaginary field lines in which any positive small charge can able to move if it free to do so in an electric field. So first we write about electric field. Electric field lines of force. And electric field lines of force field lines of force is an imaginary line imaginary lines or curved path which represent an electric field in which a unit positive charge can free to move if it do so in an electric field. So this is student about electric field. Next we can write here electric field lines are imaginary field lines, but the effect they do so are very real. For example, जो आपके घर में एक इलेक्ट्रिक बेल लगी हुई है, जब हम उसका स्विच ऑन करते हैं तो उसमें इलेक्ट्रिक फील्ड प्रोड्यूस होता है. ड्यू टू दैट इलेक्ट्रिक फील्ड द इलेक्ट्रॉन्स ऑफ in the form of gong of the electric bell hit the gong and we listen the sound of ringing the bell. So it is imaginary, but the effect of the field is real. So we can write this. Electric field lines of force are imaginary, but its effect is real situation, real situations, that is ringing sound of an electric bell. Ringing sound of an electric bell. Okay, student. Now we are discussing, or we are using some notation for representation of electric field for a point charge and pair of charges. First we write here the representation for a point charge. Electric field lines of force representation. Representation. So first for a point charge, we are using the representation of the electric field line for the both kind of charges, positive or negative. So you are understood about what is the nature of the field lines. Here we have a point charge which is positively charged. Okay, student, we are finding the field lines for this positive charge are eminent from the charge to all the directions, and we are also observing it, the origination of field lines is perpendicular to at every points. Clear, student? So we can say that the field lines for a positive charge is perpendicular to the surface of the charge, and they are radially going outward direction. When charge is positive. Next we draw this for the negative charge. Now we have a negative charge we observe here for it, the field lines are as similar to the positive charge, but for the negative charge the field lines are inward to it. That is, we say the electric field lines are terminate on the negative charge body. When the charge is smaller than 0 or negative. So here, student, this is the representation of the field line for a positive charge and for a negative charge, where the arrow is gives the strength of the magnetic field in the direction outward or inward. For the positive charge the electric field is outward, and for the negative charge the electric field is inward. Student, here one thing is also observing or noticeable, the field lines are moving radially, so we call radially outward or radially inward. Form it and write the notes. Here for this we can say not exist physically, but represent real situations. Okay student, we are going to the further characteristic for this field. Now we draw the field lines for pair of charges. Electric field line for electric field line representation. For pair of equal and like charges. When we use the pair of charges, we call a dipole. Okay, now we have 2 point charges, both are positive in nature. One is this and second is this. We observe the field lines are moving from pair of like charges, no? So we observe here the field lines are representing for a charge which are like charges are like this. So here student we observe at the center or middle of the two charges there is no field lines of forces, so we say that this point between the two like charge is a neutral point at where no electric field represents. And here we also find that they are not crossing each other, so we can write about it. This represent 1 minute. First form it. Okay. So electric field line exert sidewise pressure on each other and represent repulsive force between the like charges. Copy this. We are doing for the same pair of equal and unlike charges or a dipole. We have two charges. One is positive charge and one is negative charge. We find the field line first. Center to center is a straight line. Like this. Here they represent lengthwise force of attraction between two unlike charges. Electric field line lengthwise contract to show attraction between unlike charge. Copy this. Okay, now we can draw the field line for uniform field. Electric field lines of force to 4 uniform field. This is a charge positive conductor and here a charged negative conductor. We find the field lines are moving from positive to negative conductor or positive charge to negative charge, and here we observe at every point the value of charge is 1 coulomb. This is the representation of uniform electric field. Now student, we are discussing about the properties of field lines. Now the first property of field line is these lines are imaginary field lines. Second, a unit positive charge placed in electric field tends to follow a path along the field line if it free to do so, like this. Next property is the electric field line emanate from a positive charge and terminate on a negative charge. It is shown by the diagram also. This is a positive charge. The field lines are moving out from the charge, where for a negative charge the field lines are moving in to the charge. Next is the tangent to an electric field line at any point gives the direction of electric field at that point it is also shown by the figure. We have a electric field line, this, and when we draw the tangent to the point P, we get the direction of the field lines in the direction of electric field. Next is two electric field lines. Two electric field lines can never cross each other. If they do so, then at the point of intersection there will be two tangents. It means there are two values of electric field at that point, which is not possible. This can be represented by, these are the two field lines 1 and 2. When we draw the tangent on the point of intersection, we get one electric field in the direction called E1 and second electric field in the other direction called E2. This is not possible. Also student, because the electric field lines are the vector quantity, so they represent by the force of electrostatic force. So if they do so or they cross each other at the point of intersection, there are the two values of forces. Because it is a vector, so there is only and only one resultant force at any point in the on the field lines. So intersection is not allowed. Now we go for the other characteristic property of the field line. First copy it. Now student, next properties of electric field are, first is electric field lines are closer crowded where the electric field is stronger, and the lines spread out where the electric field is weaker. It is shown by the figure. One is capital Q positive charge, one is capital small q charge, where capital Q is greater charge and small q is weaker charge, or we call this produce high electric field or strong electric field. Number of electric field lines represent the strength of the electric field. Here for the capital charge we have the many numbers of field lines, and for the small charges few lines. So we can understood the high is the field or maximum number of field lines represent strong field, and few or minimum numbers of line or less number of line or spreading out of the line is weaker. Next is electric field lines are perpendicular to the surface of a positively or negatively charged body or conductor. We can understood this. This is a rectangular shield which is positively charged. We find the field lines are perpendicular to the surface. For the same here, perpendicular to the surface. It is very important student, when the field lines are produced or terminate from the surface or on the surface, the field lines are 90 or at right angle to the surface. Next we go for the other properties. First copy it. Okay, student. Other properties are electric field line contract lengthwise to represent attraction between two unlike charges and exert lateral sideways pressure to represent repulsion between two like charges. This we can show diagrammatically just before we discuss about the properties of field lines. Next is the number of electric field per unit cross sectional area perpendicular to the field line, that is density of electric field lines, is directly proportional to the magnitude of the electric field in the region, that is number of electric field line upon the cross sectional area is directly proportional to the magnitude of the field line. And next is electric field lines can pass through an insulator. Copy this. Now we are moving to the last property of electric field lines. The last property of electric field line is electric field lines do not pass through a conductor, hence the interior of a conductor is free from the influence of electric field. It is shown by the figure. We have a positive charge conductor and a negative charge conductor, and in between we place a solid or hollow conductor. We observe the electric field is moving from the positive charge and terminate on the conductor, and at the other end or other side of the conductor the electric fields are produced and moving to the negative charges or negative charge conductor. We observe here, student, in the conductor or interior of the conductor there is no field, that is they are not able to form a closed loop, that is this whole phenomena is called electrostatic shielding. This is the most important phenomena, student, due to which or by using this phenomena we are forming the dome or the structure of the vehicles. That is why when the lighting is done, natural lighting, so there is no effect of these lighting on the cars or buses, which are completely sealed with the conductor, so they do not form a closed loop. Complete it, student. So we are close today with the properties of electric field line. Thank you, student.